Hi, my name is Philip Haller, and I'm one of the PIs of the project Portals, Teleporting Smart Edge Services to a Serverless Future. Besides myself, the project team consists of Paris Carbone, who's a senior researcher at RISE, Research Institutes of Sweden, and also an assistant professor at KTH. And third, but not least, our PhD student, Jonas Spenger, who is also a researcher at RISE. Now, the context of our project is large-scale data-driven services. So modern digital services that leverage large amounts of data, for instance, for AI-based predictions or other services, are actually quite difficult to make reliable and scalable. Yeah. Now, data privacy and reliability are quite essential normally due to the sensitivity of the data, for instance, if you process personal information. And scalability is essential, first, due to the sheer volume of data that typically needs to be processed, but also due to potentially large user base. Now, reliability and scalability together typically require constructing such digital services as a distributed system. So a distributed system that's typically deployed on hundreds or even thousands of computers in a data center connected with a high-speed network. Yeah? Now, such systems need to tolerate faults since compute nodes or the network might fail. And the required compute and storage resources, they should scale according to the demand, according to the workload. Now, building such distributed systems poses a number of hard challenges. First of all, fault tolerance requires the use of rather sophisticated distributed algorithms. To achieve scalability, we need to use complex concurrent programming or data parallel programming methods. And to achieve a strong data consistency, that is difficult to do while at the same time providing low latency and high availability. Then enforcing data privacy legislation like GDPR can be difficult, especially if we want to automate this as much as possible. And finally, dynamically updating such digital services can be quite challenging. Now, how can we handle these challenges? And previously, there have been various system architectures and programming frameworks proposed. And among the latest developments in this field, we have serverless computing. Now, what's serverless computing? Well, here, essentially, applications are decomposed into functions, which are invoked whenever certain events are triggered. Yeah? So this is also called function as a service. Now, the key innovation of serverless computing is to automatically allocate the required compute resources according to the demand. So one can really scale up and down automatically according to the current workload. And this basically means that developers don't have to manually provision virtual machines anymore, hence the name serverless computing. Now, this partially addresses some of the requirements. For instance, fault tolerance is simplified, scalability is provided, and it's also possible to sort of roll out dynamic updates by updating these functions. However, there are still some remaining challenges, okay? In particular, enforcing strong data consistency, especially end-to-end, can be rather challenging, especially if the underlying serverless framework only provides weaker consistency. Second big challenge is data privacy. So how do we ensure the computations are privacy preserving? And as an added challenge, how can data privacy legislation like the EU's GDPR be enforced as automatic as possible? These things are, of course, essential to provide really trust and privacy. Okay. Now, the objectives of the Portals project are, first, to develop a decentralized serverless system architecture where so-called workflows can be deployed not just in the cloud, but also on decentralized edge devices. And then to develop a programming model that really supports a wide range of applications and services, where we can have multiple workflows that communicate with each other using a novel so-called portals abstraction, and where data is processed in a principled way using a so-called atomic processing contract, which I will present shortly. Third, an objective is to formalize the programming model and also the execution guarantees, and prove that the programming model actually provides the required execution guarantees and has correctness properties. And finally, an objective is to actually develop a prototype implementation that can be used for experimental evaluation and various extensions of the basic model. So one key component of the Portals framework is our workflows. So these are really the units of computation. So these are directed acyclic graphs of stateful tasks. These are known also from data flow streaming systems. And but here the workflows essentially consume and produce streams of events. So that enables building real-time applications, for instance. And workflows can be used for rather efficient data parallel processing. Now, a key novelty of the Portals system is the so-called atomic processing contract. This means that data is processed through atomic, meaning transactional, steps. So each step consists of 3 parts. First, the consumption of a so-called atom from the input stream. An atom is essentially a batch of events. So an atom is consumed from the input stream. The third part of the step is to process the entire atom by the workflow. All or nothing processing. And the third step is to produce the side effects that could be state updates, since tasks are potentially stateful, or it could be the production of new events that are produced in the output stream. But each so each of these atomic steps consists of these 3 sub-steps. And this is a rather strong contract, and the Portal system actually enforces this for each workflow, and this results in quite desirable properties. Now, one novel aspect of the system is the communication principles. So here we introduce what we call portals, and a portal essentially enables a workflow to be exposed as a service and support bidirectional communication with such a workflow. So the idea is that a task within a workflow can expose a portal so that another workflow can send requests to that task and receive replies. So for instance, a second workflow could query the state of a task within the first workflow. So for instance, the task could consist of accumulating some information that was created during the processing of the first workflow. And this communication is quite flexible to communicate between multiple workflows. Now, Portals is an open source project where our prototype implementation is under active development with multiple contributors, students, interns, and so on. And it's licensed under the Apache 2.0 open source license. The project is written in the Scala 3 language. It's a high-level language that combines functional and object-oriented programming. And the repository is on GitHub. And then interesting is that we also provide a so-called playground. So the Portals playground essentially enables running Portals apps directly from within the browser. So there is actually a JavaScript API as well that one can use to experiment with the Portals abstractions and the Portals programming model. Okay, and this is really innovative, and it was enabled by compiling the Portals framework to JavaScript. Okay, using the Scala JS compiler. So that's a Scala to JavaScript compiler. So that really enables a very flexible use of the Portals framework. Now we have a growing number of publications on Portals. The first paper shown here is presenting essentially the complete vision. And in the following, we've worked on several more publications. The Portals website has, all papers and talks always up to date. With this, thank you very much for listening.